Okay, here we are on our last part of the video, our IPv6 lab, our demo here. So let me introduce you to the lab. First of all, we have here an IPv6 host, which is connected to Vlan 2000. Remember, we are using unicast local addressing, which is generated using the algorithm as per the RFC. In this case, it's our /48. And remember, these are like RFC 1918 addressing for IPv4, right? This is private IP addressing. So this is the Vlan 2000 subnet. If you see from that /48, I'm creating /64 subnet 2000 here. Then our default gateway for Vlan 2000 is going to have the sub interface gigabit 1.2000. And this is the addressing is going to be auto-generated using UI64 algorithm. Remember, it takes the MAC address. It adds some bits in the middle and doing some math. It calculates the address. Then we have here a router that simulates the WAN link and a remote DHCP version 6 server, which is in another subnet, cafe subnet, : cafe is the address for the server. Cafe is coffee in Spanish. Let me show you real quick the initial configs for each of them. So for the IPv6 host, we have very simple, just the IPv6 address autoconfig default here. Oh, let me move myself here, because if you're not going to see anything here. So I was saying, okay, so we have here on the host, we have our interface gigabit 1 and just this IPv6 address autoconfig default and IPv6 and the RA suppress all. So what's this? Address autoconfig, this basically is saying I'm going to use the stateless DHCP version 6 service. What's stateless? Remember, so I'm going to use the router advertisements, in this case, the router, the IPv6 gateway router advertisements, right, to get the prefix that that router is connected to, and I'm going to use that to autoconfig my interface. But I'm also going to get some parameters from the DHCP version 6 server. We're going to see that in a minute. And this is just as I'm using the router as a client, I'm just saying, okay, suppress all router advertisements from this interface. Of course, if this were really a host, I wouldn't need to use this, but this is just because I'm using a router as a host. Okay, let's see how this looks like from IPv6, the gateway. If I go show run interface gig 1.2000, I'm going to see the details here for Vlan 2000. You see here, I'm simulating. I'm on a trunk link, so that is why we are using .1q 2000 for Vlan 2000. We have our /64 prefix here configured. Remember, in this case, the address for this particular interface is going to be auto-generated using UI64. And here we're going to say that we have some other parameters. So not only rely on router advertisements, but also you have to receive some parameters from DHCP version 6 server. That is this command signaling that in the router advertisement packets. We're going to say here that the interval is 20 seconds. By default, the router advertisements are sent every 200 seconds. So here we're saying to send them every 20 seconds. And here, if you remember the for IPv4, we have the relay function, the IP helper in IPv4. Okay, this is kind of the IP helper for IPv6, the relay, the IPv6 DHCP relay. So that means that we're going to send a request to our Cafe DHCP server to get the additional details. And you see here that I'm running IPv6 OSPF. So that's how the one router is able to connect our host with the server, right? Here you see very simple. This is the OSPF version 3 configuration. In the case of the one router, just using IPv. Remember, OSPF version 3 is for IPv6. and we use the IPv6 unicast address family. Then we enable OSPF on our two interfaces, and then we have here our routing table. You see here how the one router is learning our VLAN 2000 subnet. Okay, and finally here for the DHCP version 6 server, let's see what we have. We have show IPv6 DHCP pool. So we have defined our pool. I put just Slack like status auto configuration. We have defined the DNS server, which let's suppose this is the also DNS server, and our domain here, and the interface is going to put everything together. Show run interface gigabit 1. If you see here, this is the IPv6 address for this interface. So for the DHCP server we are simulating. And here, as I'm also using this as a server or as a host, I'm suppressing all the router advertisements. And here I'm saying, okay, this interface is going to be the DHCP, let's say, service, right? It's going to act as DHCP service for DHCP version 6 requests. So here I'm saying, okay, call the Slack pool, and here are the parameters that we're going to serve from here. Okay, and here is our last part of the lab. So I'm going to show you a quick demo of how all these protocols run when I enable an interface, in this case on the IPv6 host. Let me move it myself once again over here so you can see a little bit more. Okay, so here I'm gonna be on the host. First of all, what I'm gonna do is I'm gonna shut down the gigabit interface, right? So we see everything from scratch. So I'm gonna conf t interface gig 1 shut down. Okay, that's for you to see. Show run interface gig 1, right? Everything is perfect, and I'm gonna just shut it down. One more thing that I didn't tell you: the autoconfig not only says default, right? Remember, this is for IPv6 stateless DHCP version 6. Default, that means I'm gonna create also default route for this interface. So now I'm gonna end here. We have our DHCP6 and IPv6 gateway here. Now I'm gonna run some debugs, right? So I'm gonna put debug IPv6 ND. I'm gonna start seeing some messages, and I'm gonna put here debug IPv6 DHCP here as well. And I'm gonna put the same command here for the gateways, the gateway, same commands here, and the DHCP debug here on the server. Okay, let's see what happens now. So now I go to the interface. Well, first of all, you can already see that if you remember, our IPv6 gateway sends every 20 seconds, right, the router advertisements, right? What the router advertisements say. First of all, where it is sending them. It is sending them to all nodes multicast IP address, right? You see here, it should be almost every 20 seconds, it's going to be sending all the information again on the link local. And it's saying, okay, that we have a prefix, which is our FD75, A4Z1, FE01 2000 on the VLAN 2000 link. Okay, and okay, it's going to be sending that over and over every 20 seconds. Let's see if we have one more thing. No, that's all we need. Now, let's see what happens when we enable the interface on the host. Interface gig 1, I'm gonna do no shut. I'm gonna let the debugs run a little bit. I'm gonna stop them, and then we're gonna analyze what happened. So we're seeing a lot of things started to happen here. More things still going on. Let's see if the user already has all these parameters here. Show interface show IPv6 interface gig 1. And it does. We have everything here. If we do show IPv6, let's do undebug all, you all. Let's do here, you all. And let's do here also, you all. And let's see what happened on every part. Let's show IPv6 DHCP interface gig 1. And we can see here that we have received all the parameters that we need. So we have here our IPv6 address is here. I'm sorry, on the show IPv6 interface interface. We have our link local address. We have our global. In this case, remember unicast local address, which is named here as global unicast. And we have the DHCP parameters received from the DHCP version 6 server correctly here. Okay, let's see what happened. Let's go upwards on the debug after we unshotted the interface. So first of all, we see here what we have. Okay, the link came up, of course. Then the first thing that happens is that interface is gonna first auto-generate its own link local address. Remember that for IPv6, every interface on its connected link is gonna create its own link local address, and it's gonna be from the FE80 prefix, and then it's gonna use usually its MAC address and using the EUI64 encoding. So that is what is auto-generating, and it's going to run the data, right? The duplicate address detection to make sure that that address is not being used on the link. So that's what it's doing here, is checking that the IP is unique. It says, yes, it's unique. Okay, I'm going to use it. Then it starts receiving information from the router, right? It receives the router advertisements, and it's going to say, yes, we see that there is a prefix on this link that I can use. Okay, now I'm going to create my own FD75 IP address from that prefix. It does the same logic. Is going to use the prefix /64 for Vlan 2000, and it's going to use as the last part the UI64, the same as it has been calculated here for the link local address. It's going to do the same. It's going to check, okay, this is not duplicated, and here it should be around here. The DAT is unique. Okay, we're good, so we can use it. And then we're also going to request more information toward the DHCP version 6 server, right? So basically, that's what we expected. We enable the interface, we get our link local address, we get our global prefix, and we send to the DHCP server the request for the additional parameters as domain name and DNS servers. And basically, we see here that we receive all that information from the DHCP version 6 server. As we saw here, we have everything correctly configured. Okay, that's awesome. Let's see what happened on the IPv6 gateway. So on the IPv6 gateway, remember that the router is sending every 20 seconds our router advertisement. So now we see that it should also get usually a router request. Let me see if we can find it here. Received neighbor address solicitation. Here, received a router solicitation, right? So it's basically saying when the interface came up, it's actually asking directly to the router to send a router advertisement. That's what the router replies with a solicited router advertisement. That basically means instead of just waiting for 20 seconds, I'm going to send directly a router solicitation to get the information quickly. And here, the router is going to send, right, all the prefixes and all the information that the client needs, right, to get the prefix and to auto-configure its interface. And remember, on the router advertisement, we also have the parameters that say, make sure that to contact the DHCP version 6 server because we have more information for you. And remember, as this gateway is the DHCP relay, it's going to send that request to the DHCP v6 server. And here's basically what we have from the DHCP version 6 server. We receive the request, and we basically send back the reply with the information of the domain and the DNS servers. I would say if we say show IPv6 DHCP bindings. No, we don't have here, but yeah, sometimes you can see some more information here, but that's fine. Okay, I hope that has been informative for you. This is all we have for today. Hopefully you get the idea of a simple network with IPv6 and in this case, the stateless DHCP version 6 configuration and everything that happens from this network discovery protocol and how it looks in a lab scenario. So finally, what we can say here, let's do a quick ping, show run University 1. Here's our cafe address. So let's see here from the host, it should be able to ping the host back to the server. The host should ping correctly the server, and it does. And if we do a trace route, we'll see the 3 hops. We're going to do numeric, right, to avoid the resolution of each hop. And you see that we have here, this is the IPv6 gateway address. This is the WAN router, and this is the actual cafe server. All right, guys. Thank you for watching. See you in the next video.